Professor?
Yeah, just a second.
Okay, no worries.
Looking at something else.
No worries. I just had a quick question about the immune system, since this is technically the last day we're going to spend on it.
Yeah.
Oh, do you want me to go ahead and ask it?
Yes, go ahead and ask.
Oh, so for like autoimmune diseases, I understand that it attacks like our own cells. Does that mean they're detecting the self-antigen?
Generally, that's what's believed. I know there's a variety of reasons why you can have autoimmune. Some have a genetic component, but some of them, one of the reasons they treat you for strep throat, Streptococcus pyogenes, is it tends to fool your immune system into, probably not intentionally, but into reacting to a self-antigen that normally it wouldn't react to. So probably some antigen on the pathogen somehow looks enough like a normal antigen, but enough different. And then your immune system kind of crosstalks and ends up attacking your heart and your kidneys when you wouldn't otherwise have that happen, except you had the streptococcus infection. So there are certain viral infections or bacterial infections that seem to trigger it. So it just may be kind of error management in your, in the specificity between the antigen that's on the pathogen and a self-antigen that's one gets mistaken for the other. But there's certainly other ones that they have no idea why you get, and like diabetes, they don't really know, and sometimes there isn't even any genetic correlation. So late onset is pretty well correlated genetically, but juvenile diabetes or early onset is not apparently very well correlated genetically, and yet people get it, and it's an autoimmune.
I didn't realize diabetes was an autoimmune disease.
I think they believe that that's what's happening. I know that that's what's happening is you're eliminating your beta cells. Your immune system is eliminating the beta cells. So.
Okay, cool.
Yeah.
Thank
you. So how are we doing there? Okay, I guess we should get started. So what I was doing, but I didn't quite finish, so I'll try and make it before I leave for today. I'll have a new version. It's not that big a difference between the study guide, Lab Study Guide 2, and the Lab Study Guide that I'm going to replace it with. So if you printed that study guide out or something, download a new one by this afternoon. And content-wise, it isn't all that much different, but I thought I'd clarify a few things. So I'm going to share the screen with you. And if you were there in the early part of the lecture, I kind of already, did I get the right share? Are you guys seeing the study guide? Share screen. I may not have gotten the right share. There we go. Is that the study guide? You can give me a thumbs up, somebody, if you see it.
Yes.
Yes. Okay, great. So why I'm doing this is because I graded the lymphatics assignment, and there seemed to be a lot of confusion in the lymphatic assignment. And it may be because even though I think this is clear, and some of you did understand it, that if I'm mentioning these things that you should be labeling, then you should be labeling them on these slides. If there's germinal centers in more than one slide, you got to label it on more than one slide. A lot of people missed even drawing this slide. What I added here is that there should be a minimum of 6 drawings. Now, in this case, for the lymphatic slides, I don't know why, but there weren't good pictures in the lab manual to help you. But I mentioned that the textbook has good pictures. So if my comments, when you get them, when you open those up, say you didn't label anything or you labeled things wrong, then use your textbook pictures. They have fairly good labels. The other thing I did with these, which I didn't do in the respiratory, if I remember right, is I kind of made a challenge for you to know which slide is which organ. So some of you labeled the drawing by lymphatic slide 2, lymphatic slide 3. You may want to change it. I mean, sometimes you could tell from how you discuss the slide, what labels you put on. You knew that that was the thymus, but maybe you'll want to change it so it says thymus. I kind of challenged you to know what you're drawing by, drawing it and then identifying it, as well as putting these labels on. Were there any questions about this? Let me get chat open in case you can see. I hope I brought a battery here. Okay. All right. So, so let's talk about the slides for today. And before I leave that, are there any questions about doing these measurements? Hopefully this is due at the end at 5 o'clock today. So hopefully this graph with the measurements, showing me the measurements and their averaging. Okay. So I'll just say that from emails, the only confusion I kept hearing was, do I use diameter or radius? And I thought I went over this, but if you can see a diameter, you're going to measure diameters 3 times and average them. If for some reason, like this guy, you can't see it, then you're going to have to use a radius and double it to get the diameter, but I'd still do it 3 times. Now remember, when you do the diameter, just don't make an X through here, kind of guess where the middle is and keep going through the middle, so you're not, measuring here at 1 and then measuring here and another. That's not very good with this little plusy thing that this shows, but so it's going through a common central point. So so whatever error in picking the central point is the same for all the measurements you do. Any questions on that? Okay, so turn that in. I actually made it worth 10 points. It's worth quite a few points. So put your best effort in there. Make sure that you know what you're doing, because it's a little more points than you might expect, maybe. All right, so going on to the gross anatomy of the respiratory tract. I may go through these slides really quickly. Well, I'm not going through them at all, or these lecture questions really quickly, or even just to speed things up like I did today, not break you up to discuss it. Because the upper tract has lots of structures whose primary goal, as far as respiratory system, is to do these 3 things: warm, moistening, and filtering. So as you go looking at the models, if you see a structure like, say, the concha or the vibrissae in your nose, they both aid in doing these things by causing turbulence in the movement of the air. So here it talks about turbulence. So think about it as you go. Don't just say, for example, what would be a bad thing to do would be on the lab test, I say, what is the function of a concha? And you say warm, moistening, and filtering the air. It's true that it helps in doing that, but you could say that same function about all the structures that cause turbulence, or that secrete mucus, or that blood vessels. It's too broad. You've got to focus in on how it does these things. So, for example, with the concha, they increase air turbulence. They're also lined by mucosal membrane with pseudostratified ciliated epithelia. They secrete mucus along that lining. And, there you have it. You've got lots of things you could say about how the concha increase air turbulence, and therefore, and have this lining, and the lining causes mucus. So mucus moistens, the blood vessels warm, and the filtering occurs because of the trapping of the mucus. And all of that is increased by this turbulence. Is this making sense to you guys? Let me see what's in chat. Okay. Looks like you guys are talking to each other. All right. So let's talk about the slides, because what I'd like you to do where it's appropriate is, and I hope I'm still sharing the screen, is to be able to recognize and know the tissues and why different tissues exist along the length of the conducting zone. So I think I skipped over that quickly, didn't I? Conducting zones move, as the name kind of implies, is moving the air from out here in the world into the alveoli pockets of your lungs. So it's like a set of tubing, right, for the air to pass through. And as it's passing through, it's getting warm, moistened, and filtered. The respiratory zone is only the alveoli surfaces themselves, where you have simple squamous epithelia and you get rapid exchange of gases by diffusion. So deep in the lungs, you're going to have bronchiolae and bronchi. They're still part of your conducting zone. So when you're looking at the lung slide, you're going to see some conducting zone and some respiratory zone. But other than that, most of the rest of the slides, you're looking at the conducting zone. So in that conducting zone, this is considered a mucous membrane, and it has these layers. So for the respiratory, you remember mucous membranes, you might recall, include your digestive tract, your respiratory tract, and your urogenital tract. There are variations, but the 4 layers you see here are seen in all of those mucous membranes. It may be that there's no muscle in some of them, and it's replaced by something else like cartilage that you'll see in your respiratory zone. But they still are calling it the muscularis mucosal layer because that's normally where you'd find it. It's the 3rd layer in. Is that okay? Any questions about that? Nothing new showed up in chat, I guess. Okay, so the surface epithelia is, as the name tells you, it's an epithelial layer. So it's one of the epithelial tissues that you studied last semester in 103A. And for the respiratory zone, you have 2 subtypes of epithelial tissue. It's pretty easy to remember. If food and fluid and air all share a common pathway, then that is stratified squamous. So inside your oral cavity to the very top of your larynx, it's all stratified squamous because the epiglottis, which is covered with stratified squamous, is going to be sending the food and fluid down your esophagus, but the air will go down the rest of the larynx and into your trachea. If you're above the mouth, so you're in the nasopharynx, then you're going to be pseudostratified ciliated. If you're below the epiglottis within the larynx itself, it transitions rapidly to pseudostratified. So if you're in the conducting zone, which is where you have this is conducting zone, those layers, then your only choices are stratified squamous or pseudostratified ciliated columnar epithelia. We all right? You just have to say and ask yourself, under normal conditions, is food and fluid in this passageway as well? If it is, it's stratified. So when you're looking at the models of, say, the half head, I sometimes will put a label on a part of your pharynx or your oral cavity or your trachea and say what subtype tissue lines passageway, and that's what I mean, epithelial tissue. Now, under epithelia, you have to have areolar connective tissue. Just like in the skin, you have to have it because epithelia is avascular. So you've got to provide blood vessels to keep this guy alive, and also there are immune cells in there, and there's connective extracellular matrix to link to the basement membrane of these guys. to hold it all in place. So the lamina propria, which is a kind of hard name to remember, but we're going to keep encountering it, is the name of that areolar connective tissue just beneath the epithelia. Now, sometimes this is quite thin, and it's areolar doesn't stain. There's not a lot of fibers in it very well. So sometimes it's a little hard to see this, and all you have to know is it's there. But if you can see it in the slide, then label it. Okay, so this then fuses to a fibrous connective tissue. This has got a lot more fibers. It's denser cells. You tend to see this pretty easily. And embedded in that can be the lymphatic follicles or nodules. So Peyer's patches is in this submucosal connective tissue, this fibrous connective tissue, but they're little islands of reticular connective tissue, which are the lymphatic nodules. Well, not so little if they're Peyer's patches. Sometimes there are also glands down here. So glands are always simple, cuboidal. And you are going to be looking for glands in the tracheal slide. That's the only one you're going to look for glands. And in the trachea, glands are not evenly distributed, so you have to be careful. You have to kind of look through the slides of the trachea to find them. Okay, so that's the submucosa. So what you're learning here, we're going to use again in the urinary system and the digestive system. So you're going to continually be looking for these layers and these mucosal membranes. Now, in the case of the respiratory system, sometimes you have muscles in the muscularis mucosa, but that is largely when you're in the bronchioli, down deep in the lungs. There'll be smooth muscle. With the exception of a muscle you're going to look for, you're not going to see muscle in the trachea. Now, there is one place there's a muscle, and that's at the backside. So your trachea is a ring of cartilage has replaced this muscle. But on the backside, right under your vertebrae, you have a thin strip of muscle, and it's called the trachealis muscle. And we'll talk more about it probably in lecture, but it helps to increase the speed of air when you are, say, sneezing. So air will go zooming out really fast. And it also relaxes. That's when it's contracting. When you go to swallow, there's a reflex that causes it to relax so that your food in your esophagus can kind of bow into the empty cavity of your trachea, kind of like, think of a snake, the food going down. Okay, so that, if it has muscle, say down in your bronchi, this is going to be multi-unit or visceral smooth, but in our case, it's multi-unit. So this says or visceral, probably shouldn't say or visceral for the respiratory system. There's only multi-unit in the respiratory system. In the digestive, you can see visceral. So I'll probably edit that before I post this tonight too. Whoops, sorry. I forgot I'm not on the slideshow part of it. So let me grab this over here. Come on. There we go. So the last layer is another fibrous connective tissue layer. It tends to be much looser and sort of pulled apart because it fuses to the fascia around it. So if you're way up in your upper respiratory tract, it's going to fuse to the epimysium that's on the skeletal muscles around that area, or in your throat, it's going to do that. So it's often a little bit hard to see. And when they go to dissect that organ out to make the slide, sometimes they remove nearly all of it. So it kind of depends, but I would know it's there. Now, when it's in the embedded in musculature, it's not in your thoracic cavity, it's called adventitia. But once it enters into the thoracic cavity, then it's actually part of the serosa. It's not necessarily adventitia. It's still a fibrous connective tissue, except in some places where it's areolar. Again, we'll come back to this, but All right. So here are some of these variations you're going to be looking for. I already talked about this. For layer 2, the only time you're going to be looking for a specific muscle, specific glands is in the trachea. And then you're going to be seeing tracheal glands that release mucus. And smooth muscle is mostly replaced by hyaline cartilage until you get down to the bronchiole, and then it's almost entirely smooth muscle. Okay, so one other thing to try and make your life a little bit easier, I thought there's a distinction in the lab manual in the book between a terminal bronchioli, where you have entirely smooth muscle and no cartilage, and a non-terminal bronchioli, where you have little patches of cartilage, but not a ring of cartilage. Well, it's hard in the slides to know, is that a ring? Is it a patch? So I just tried to make it more black and white and say, if you see cartilage sitting within that third layer, we'll call it a bronchi. If you see no cartilage, you only see muscle, then we'll call it a bronchiole. So we won't have any bronchiole with some cartilage. We'll only have bronchi with cartilage, bronchiole with no cartilage, just to make it totally black and white. Now, the other variation is at the very terminal end. What happens is these tall pseudostratified, and it happens really quickly, they go rapidly down and become simple squamous epithelia in the alveoli. But they're short at some places, so they look like simple cuboidal, and the book will even label them soup. But it's very quick. I mean, probably within 3 cells or so, they're already down to squamous. Okay, so that's the conducting zone. When you get down to the respiratory zone, there are sacs and ducts. And the way to know if you're in a duct is it should be linking like a passageway between 2 sacs or between the bronchioli and a sac. The way you know in a sac is it's got a nice wall around most of it with just a duct, an opening to that, which goes into a duct. Otherwise, functionally, they're the same. It's just like 2 roads with different names. Functionally, they're all the same. Now, they're made primarily of simple squamous, and that is all you will be able to see. You just have to know there's a few simple cuboidal. You can't see them because they're even then pretty flat cuboidal cells. They're not, squares. They're pretty flat. So that is all you'll be able to tell in there. Ducts, sacs, know they're simple squamous, and just be able to tell me that there are these type 2 cells in there. When you're in the alveoli, you've left a mucosal membrane. It does not secrete mucus in the alveoli, so you're definitely not going to get the layers because it's exceedingly thin. It's exceedingly thin, not thick. Okay, so let me look at the next slide. So I think this one is a little more specific than the one you got in that the slides are labeled in the folder. You know that you're looking at posterior larynx, anterior larynx, excuse me. You know their magnification, and it tells you what to be able to recognize here, but also add to this that you should be able to recognize these mucosal layers if you're in the upper respiratory tract, or in the conducting zone rather. So until you get to the alveoli, you should be able to tell me which layers and what subtype of tissue we're talking about. So if in the bronchioli, I point at smooth muscle, you should be able to tell me it's multi-unit and you're in the muscularis externae layer. Same thing with the cartilage. You should be able to tell me it's hyaline and you're in the muscularis externi layer. So, there's a chat here. Okay, something else. I loaded graphs. Okay. All right. So there is one slide of a pathology, and that's emphysema. So we're going to talk more about emphysema next week. But in order to appreciate what emphysema is doing, you need to draw a normal lung at the same magnification. So there is a slide that has normal alveoli plus bronchioli all together. And then there's a slide that's all alveoli and all alveoli. So try and match these. I think it's called lung alveoli or normal lung alveoli in the thing. And you're going to draw these at the same magnification, so you can see that what happened in the emphysema is that the sacs get bigger. So, so what does that make it? 1, 2, 3, 4, 5, 6, 7. That means you have a minimum of 7 slides that you're going to be turning in. These are not due for a while. I think I brought the syllabus. I believe they're due on the day of the exam, the lab exam. So you have a little bit to turn them in, or the day before the lab exam. I unfortunately didn't print out the next page of the syllabus. But take a look at it. They're not due, at least they're not due next week. So you do have time to draw this. Now, before I let you go to work, there are lots of models, and I did make lists of what you should be able to identify. I did not make labeled versions of these because the pictures in the lab book. So if you have questions on these, the pictures in the lab book are a pretty good match. There's no match to this one, but I don't put it on the test. I'm just using this one because it shows you the effect of the concha on the nasal cavity. So, it's quite a labyrinth in here. But the rest of them you've either had, like this half skull in 103A, or there are pictures in the lab book that match things like this pretty well, or this. So if you're I would work on this before we meet again next week. So on a Tuesday of next week, I say photos of drawings of respiratory anatomy with labels. I actually do tell you you're supposed to turn it in. Why don't we move that to Thursday? That gives you to Thursday to turn in the respiratory anatomy ones. We're supposed to do a review for the test. We're going to see how that works out. Right now, Kevin, right as we speak, is trying to make another YouTube. He has one for spirometry, but we're trying to make it so it matches your lab book a little bit better. So that's why I'm thinking next week, stay tuned. I may be switching these things around. So the spirometry and the review might get flip-flopped a bit. And I might even find that I have to push the exam off or switch it with urinary anatomy. And that way we would open up doing another lab for review. So if I edit the syllabus once I hear back from him, I will let you know. And if I end up pushing the exam to the 29th, let me know if that makes some sort of huge problem for you. It would be moving it from a Tuesday to a Thursday. So if you can get to these last respiratory models, notice that these guys are all muscles that you studied in 103A. So you're reviewing all of these guys. If you can get to that, which is slide 27, working on the models, and come up with whatever questions you have about them, and then start your slides and come in with whatever questions you have about those on Tuesday. I will say the slides then would be due Thursday instead of next Tuesday. And we'll go from there. Okay. Any questions? I got something in chat. Maybe just you guys. Okay. So let me put it in here so you see it in typing now. Slide drawings on the respiratory slides are due Thursday, the 22nd. 5. And I'll change that in the assignments so you won't all get late notices on those. And stay tuned for date modifications in the syllabus on especially the spirometry lab and review. Okay. It's already the 2nd. That's what Jennifer said. It's already due in Canvas on the 22nd. Oh, good. Then I must have an older version of my syllabus here. So that means one less thing for me to do, and you now already know it's the 22nd. So I will find out today from Kevin if he can get that up. So if he does, make sure on soon, over the weekend or Monday, you get a chance to watch the YouTube videos on spirometry. Okay, any other issues, questions? Okay. All right, so I think most of the rest of this is pretty clear. I'm not sure I really need to edit the study guide, but I may be adding some spirometry stuff at the very end once he finishes, so it matches, the study guide matches what he's doing. So if you can, again, pay attention to the study guide and see if we've made, it would be additional slides at the end, if anything. Then that would be most helpful for your studying for the lab test. Okay, well then at this point I'm going to stop sharing, and everybody knows where to find these slide drawings, right? Any good? Okay, thank you, Daniela. Great. And if you're all ready, I will be here, and I'll be online at least for a little while. I have 28% of my power, and I don't know if I have a power cord here anymore, but I'll be online. And so just shout out and let me know if you need any help, or if you're lost in finding something in the folders of the models or the slides for the respiratory system.
Professor?
Okay. Yeah, Noah.
I was actually wondering if you would go over the slides, because I tried doing them this morning in our downtime, and they were just all really confusing because I tried to reference them to like actual other online sources, and other online sources were sort of different.
Other online sources or your lab manual?
I also tried the lab manual, and it wasn't very helpful either.
Okay, well, let me open this. So, you know what I might do, if you haven't gotten it before, I might put into files the histology book, which again is not perfect. Nothing's going to be the exact same picture as our slides. It's just impossible. Histology lab assignment 2, respiratory histology. So this is just showing you, so oops, I'm not sharing the screen. Share the screen. I'm going to move all this over. So I didn't have this in that list. It's just showing you what the lung alveoli, and you can actually see, can you see where I'm pointing on this and all?
Yeah, we can see.
Yeah. That's the bronchi. This is actually a big blood vessel full of blood. That's what the red is, if that's not helping. None of them are going to be perfect. You can see all these pockets, and I put this in here so you can see that there's kind of a bunch of bumps here, where all of them meet. So you have a duct and a sac, but it's up to you whether you draw this. I don't think it's on the list of things you draw. Oops. Oh, when I close the window, it stops sharing the slide. Great. I'm going to keep sharing the slide again. So this is the alveoli and an alveoli duct at 400. Let me share the screen again. So you can see those same pockets. So here you've cut the pocket so you can't see where it links to the others. But here, this one is cut so you can see the duct that links these together. So there's one sac here. There's another sac that's a bit folded right there. And this is actually the little cuboidal cells right at the end of a bronchiole. So here's a sac going in through a duct to another sac. Is that giving you the idea of what you're looking for? Any questions? You'll need to pop them up because I'm going to have to go through these quickly. Okay, let me see. All right, now the larynx, I forgot to mention this, but this one is really useful if what you do is make a compound picture, because I can't go low enough in magnification to, let's put the screen share up again, to show the whole cross section at once. This big wide opening right here, that's the glottis. This is the esophagus. Now, how I know that is the esophagus tends to collapse when you're not actually swallowing. And so it's a fairly narrow passage. And the other main way I know is if I went to higher power, and you can almost tell that here, this is many layers of cells, the stratified squamous, stratified squamous. So the entire lining is stratified squamous. So this would be like 1/2. And then if you make the composite, you're going to have a big wide glottis here. And then over on this side, which I'll show you in the next picture, will be the epiglottis. And so let me, I guess there isn't any way to do this. Maybe if I open all of them. What happens if I open all of them and then anterior post is probably alphabetical, huh? Posterior larynx. I've got 2 open. Let's see if I can go to the second one without losing the screen sharing. Yeah, it looks like I can, at least to some limited extent. So I know the orientation is a bit off. You know what? I made a mistake in that. I'm going too fast here. This is the esophagus. Let me go back again. Let me try and make this orientation. Let's see if I can leave both of these together so you can see what a composite would look like. I think this one is the one that you won't find any reference material, so I'm spending a little more time on this. Okay, so here we go. Share these 2 together. I can't open both of them. Let me hit share.
那个云呀，云就是符呀。
Can you turn your microphone on? Whoever has it on, June, or?
啊，符了。
然后他那个靠不上服务，服务就说一个人帮你剪头发那叫服务，那个不上。
那个呢不怎么不上符了？那也是产品啊。
那也是产品。
Okay, maybe they're done.
No， 走可那个
Everybody's muted.
云服务，云到底是产品还是服务？
Okay, there we go. All right, so this, I'm sorry, I misspoke. This is not the glottis. That's a torn edge here. I think I just should have looked at these before. This is actually the epiglottis with the epiglottal cartilage. This is all stratified squamous, like I said, because the epiglottis is covered. This is actually part of your oral cavity where the epiglottis is kind of flopped back towards. And then if you could put this on one side, and can you see both of those pictures now? Are you seeing 2 pictures?
No, we only see the first image you put up.
Yeah, unfortunately, I can't show both of them at the same time. So the one I'm showing you right now, this is the glottis right here. And then the other picture, which I now have to stop sharing that and start sharing, this is a pain in the butt. This one. Here's the glottis for this one. And this is the esophagus all collapsed down. So the glottis is the big open passageway that the air is going through. If you want to, you could make one big picture with all this put together. And you might say, why is there this thing that looks like an epiglottis? Well, as you'll learn when you look at the models, the retinoid and cricoid cartilages stick up like that in the back, and they form the backside of your larynx. And they also, with the retinoid, they connect to your vocal cords, the muscles, so they actually move to help your vocal cords move. So this is the cartilage of the back of your larynx. Whereas, let me stop share and share again with the other one. I'm spending quite a bit on this one because I want to make sure you understand this one. This is the epiglottis. Are we all right? This is the glottis. And this is just the back of this is all stratified squamous, like I said, but this is all the back of your oral cavity. So that one, there isn't any reference, and maybe that's what you were struggling with. I can't go through all of these probably, but here is, this should look, let me stop sharing and share again. This should look like some of the things in your book, I would hope. This is cartilage. I hope you recognize that's hyaline cartilage from last semester. This big opening is your bronchi. This is actually part of one of those rings that go, to keep that tube open. Here's pseudo-stratified ciliated. I know it's pretty low magnification, but you can see there are tall cells, and there's mucus on top. This is a whole bunch of mucus, and these are pseudo-stratified, so this is still a bronchiole. This has not got pseudo-stratified. I know maybe it's a little low magnification to tell, but this is blood. All that stuff that's filling it, that's a blood vessel. These are alveoli. Can see if I can find any ducts here connecting some of these alveoli. They're all just in cross-section. Oh, here's one with some ducts connecting here's an alveoli with a duct, another alveoli. The duct's a little less obvious in that one. Are we okay? Is this what you're needing, Noah?
Yeah, that one, I guess I didn't see that image, but that one was a lot clearer than the other ones.
Okay. Let me close some of these so I'm not going to get too confused. I can now open a couple. Is there any other inferior larynx and esophagus? I think I already had that.
Do you happen to have a slide with the smooth muscle for the trachea? I couldn't find it.
So here's the terminal bronchiole. It's not the world's best picture. So here's the bronchiole coming in. Oops, I'm not sharing. Sorry. I got to do that step too. Oh, yeah. Let me see if I can make this picture a little bigger too after I'm sharing it. I can always expand it out and I can make it a bit bigger. What I'm talking about is here's a bronchi. You can see the pseudostratified. You can see it's going pseudostratified. This is into a terminal bronchiole. And all along this bronchi, you can see there's a lot of tissue right here, right? It's all dense, lots of nuclei. This is all smooth muscle in here. So by just knowing that this is the epithelia, you're going to have the very little in the terminal bronchiole and the ends of the bronchiole. You're going to have very little submucosa. You're going to have mostly smooth muscle. So most of this that you're seeing is smooth muscle. That's probably a blood vessel there. And I apologize. I know it's not. It might be cartilage. It's not a very good. Let me see if I make it bigger. Just gets blurrier, but at least you can see these are tall cells, and this is muscle, these patches here. And there's very little submucosa, but probably, just this thing that's kind of a even layer underneath is submucosa. These patchy things are muscles. And that's cartilage, I can tell now when we go up, because you see the bubbles, that's cartilage. Is this what you're going for? There's even still smooth muscle in here, in this. Right? Can you see the pointer I'm moving?
Yeah, we can see it.
Yeah.
I just wanted to make sure for the trachea, because I don't think on any of the slides I could find any smooth muscle for the trachea.
Yeah, the only smooth muscle in the trachea is that trachealis muscle. So let me go to the trachea one. Now, of course, I didn't label it as trachealis, did I? So I have to see. Let me open a few of them. Yeah, that one's not. Maybe I'll open a couple of these because there's some things that can. Yeah, there it is. Okay. All right. So remember, the trachealis muscle is bridging the ends of cartilage. So are you seeing the slide with the arch, and it's sort of arching from 3 o'clock to 9 o'clock?
Yeah.
So here's cartilage. Here's the submucosa. And you can see along the edge, there's some epithelia. It's always pseudostratified there. And then this cartilage ends right here, and it turns pink. That's because this is the trachealis muscle. So for most of the trachea, the diameter of the trachea, you have cartilage replacing smooth muscle. It's just at the very back, you have this trachealis muscle. Because when you go to sneeze or cough, this will contract and make the passageway narrower. That'll make speed of the air go out faster. But generally, you're not trying to regulate airflow through your trachea. Unless you're doing something unusual like sneezing. Let's see, can you see this one now? This is now arching from like 11 o'clock to 5 o'clock.
No, it's still the same image as the
okay, so I have to stop sharing. I thought if I had two of them open, I could do that one. So I only want to show this one. This is, again, the tracheal cartilage. It's a little higher power. Here is that's in the muscularis mucosa externae, although there is no muscle there. There's just cartilage. This is your adventitia. This is the submucosa. And amongst the submucosa, there's lots and lots of blood vessels. These are all blood vessels, not glands. And then you have the lamina propria. You can see it here. And you can see the pseudostratified right there. If we look at, this is low power. No, that's low. There is another one. Let me go. That's blood vessels still. I thought I had one with the tracheal glands. Let me see if I can, oops, I stopped sharing. Of course I did. Go away. Maybe I didn't put that one in. That's blood vessels. If I didn't put that one in, there's a bunch of them that looks like I meant to put a tracheal gland, but I didn't. I got two of them that are the same thing. Okay, so that last set of 4 trachea, probably trachea number 3, I'll put something like tracheal gland instead, because that's a redundant with the last one that just says trachea 100. It's the same picture, so I probably didn't get the gland one loaded up here. So, okay. I don't know if any of the others, is there a particular other one that you want to see before we end this?
I think it was all right with me. I'm still a little confused on the larynx, but I think I'll be able to manage.
Yeah, no, that's the problem. I've even gone online and I haven't yet to find a good picture. So what I would suggest with the larynx is study the model first, especially the model that is, let me see if I can get in, share the model. Study this model and it'll make more sense to you. Where our lab assignment 2, And lab assignment 2 models. And where is respiratory tract models? Interior of the larynx. And I think this one, share the screen. Let me see if first I can do is keep my rotated. Okay. So I would study this picture or this model and then try and relate. So the glottis is this, right? Is this space. Are we okay with that? Where the air is? We all right?
Right.
Okay. So where we're looking, now what's missing out of this, which is not helping us, is the esophagus, which would run right here. Esophagus is running right here. This is where his mouth is, up here somewhere. So here is the epiglottis. And remember when I pointed at the epiglottis, there was kind of a part of the oral cavity. That was right here. That's why this sticks up. And then here's the glottis again. So that's the cartilage for the epiglottis. Here's where the stratified squamous would be. And then stratified squamous all through here because your esophagus would run right here. And then it looked like something was sticking up. Well, it's this piece of cartilage. This piece of cartilage is called the arytenoid cartilage. That's blue. And it also sticks up and pulls away from the epiglottis, or the esophagus, which runs right here. This is the cricoid cartilage. So in the slide, all you see is this cartilage. It's not quite as arched as this model is showing it. It's more standing upright like that one. And so there's like a little tiny V, but the esophagus is all collapsed down against this. And all of it is lined by stratified squamous because, food and fluid. Well, this is opened, and then when you swallow, this actually flops down over here so that the food will kind of travel around the backside of that and go down your esophagus. Is that helping orient? So we're not seeing any of the part except we're seeing right from here up, kind of. That's the part we're seeing in the slide. We don't get to see any of this.
So just assume the open space, like the vast open space, is the glottis then?
That's right.
Okay.
Yeah. And it should be the vast open space. In this case, there's a big tear right here, just kind of like it is in the model. And you'll see fat. It'll be just like in the model here. There'll be fat, and we don't have the bone, but it would have been there. And it's kind of torn looking. And over here, you have a very narrow space that collapses down because the esophagus is just all collapsed down on itself when you're not swallowing anything. Okay. Okay, other questions? All right, well, let's check in again on Tuesday. And right now what's scheduled is the spirometry, but that may be bumped up. And in that case, if you still are having questions about any of the slides or models, we can talk about those. And then it's not due until a week from today. So whatever struggles you're having with this drawings, you can check in with me on Tuesday about. Okay, I don't think there's any new chats, but let me just double check. Okay. All right. So I'm down to 19% power. So I'm going to have to probably log off, but I will be back. And I also have to leave campus. I'm not allowed to be here more than 4 hours. So I don't know why, but anyway, that's what they say. So if I'll be around today, so if you have questions, just email me them, and I'll stay online for, I don't know, probably 10 minutes or 15 minutes. And then you can just reach me by email, but I'll stay with the Confer Zoom open if you want to get started. All right. See you, hopefully, with my internet working on Tuesday. Have a good weekend otherwise. All right. I'm just going to turn the camera